So this video we're going to talk about how you can reshape a vector, reshape an array. And the concept is if we have an array that is of a certain dimension, this one will be a 3 by 3, that we can reshape it as long as we preserve one simple rule. And that simple rule is if this is our original array A, and let's call the number of rows here R1 and the columns here column 1, and we want to reshape this to some array B, we'll call that rows 2 and columns 2, then the rule is that rows 1 times column 1 has to equal row 2 times column 2. And what I mean by that is the sort of the area of the original array has to be equal to the area of the reshaped array. So if this is a 3 by 3, then I can reshape this to a 1 by 9, or I could reshape it to a 9 by 1, and this is one sort of difficult to preserve with any other reshaping dimensions. Let's go over here to MATLAB and let's see it work on a different array. If I run this, you see here we have array A and array B. Array B is a reshaping of array A. In fact, let me do these two on the board as opposed to the one I proposed here. So if I have array A, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is a 4 by 3 array. Well, what I did with B is I reshaped A to actually be so B equals 1, 4, 7, 10, 2, 5, 8, 11, 3, 6, 9, 12. This is actually a 3 by 4. And so what I asked myself is 4 by 3 A equal to 3 by 4 B, and it is. So the area, if you will, has been preserved. Well, how did MATLAB know how to rearrange? Well, this goes back to the linear indexing. If you look at the linear indexes here, this is 1, 2, 3, 4. Remember, you go down and then down 5, 6, 7, 8, 9, 10, 11, and 12 on the index, right? Well, if you look at the reshaping here, we simply did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so MATLAB uses the indexing and the reshaping. You told it that you wanted, in this command here, we said reshape array A to be a 3 by 4. So it knew we had to have 3 rows and 4 columns. And so then it used the linear indexing to just go down the columns, down the columns, down the columns to fill this 3 by 4 rectangular box, if you will. Okay? And so let's look at some other examples of how this works. So that's reshaping it to a 3 by 4. Now let's reshape it to a 6 by 2. Let me comment out this line. Uncomment that one. So now on line 10, I say reshape A to a 6 by 2. So now it has 6 rows and 2 columns. But note that the linearized indexing remains the same. I'm changing the row column indexing, but I'm actually leaving the linearized indexing in place. So I start off here. This is 1, which is the same linearized 1 up here. 2, 3, 4. If you look up here, 2, 3, and 4 is the 1, 4, 7, 10. And then 5 is the 2. 6, the linearized index 6 is the value 5. 7, 8, 9, 10, 11, and 12, just as we have up here. 7, 8, 9, 10, 11. Excuse me. 9, 10, 11, and 12. So that's the linearized indexing in this box, rectangle if you will. And now let's see the dimensions 6 by 2. If you multiply those together, you get 12, which is the same as the original 12 that you got from the original 4 by 3 that you have for array A. Okay, let's look at another example here. So this is D. It says reshape A to a 2 by 6, 2 rows, 6 columns. Once again, if you check, your linearized indexing still holds place. This is 1, 2, 3, 4, 1, 2, back up, 3, 4, and all the way through. So once again, 2 times 6 is equal to 12, 3 times 4 is 4 times 3 is 12. So the area, if you will, has been preserved. Oops. Another example. We can do a 12 by 1, so that's just straight down. So 12 rows, 1 column, which is a vertical vector. And the linearization 1, 2, 3, 4, 5, 6 is preserved 1, 2, 3, 4, 5, and 6 all the way down. And then the last one, I'm going to have to get wider here to make this fit. If I run the last one, it still didn't fit all the way. It is a 1 by 12, so it is a vector. So I can take any array and squish it down to a vector by our definition of a vector. And so linearization 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and so on, all the way through to column 12. So there we go. So the whole idea of you can reshape an array to be sort of the shape that you want it to be, as long as you preserve the quote-unquote area, which means the rows and the columns of the original array. You multiply those together, have to equal to the product of the rows and the columns of the reshaped array.